ladies and gentlemen, welcome to Math 30-2, Chapter 1, Set Notation, Part 2. Now moving on to beyond definitions to mathy stuff. When I give you numbers, you should be able to find a pattern. Well, not always, but you should be able to. So for this green block here, 1, 2, 3, 4, 5, 2, 5, 7, 9, 11, note X and Y. The first one is always X, the second one is Y. Now pay careful attention. Soon I'll be showing you how to put this in your graphing calculator and graph it. So instead of X, I might refer to it as L1 as in list 1, and L2 as in list 2. Either way, note there is a, more importantly, there is a pattern here. Every time X goes up by 1, Y goes up by 2. So you should be able to look at this and realize the next number after 5 should be 6, the next number after 11 should be 13. Alright? Now, I'm going to pause the recording, and I want you to do the same thing for examples 2 and 3. We'll come back and compare answers. Okay? Okay, ladies and gentlemen, so this is going to be X and Y. So you should know this goes up by plus 1. So the next number is 6. This goes up by plus 4. So this should be 24. And same for block 3. This is X and this is Y. X goes up by plus 1 every time, and Y goes up by plus 1. So this should be 6 and 5. So if you see that, you're seeing the patterns, and I'm happy. Now, going on to some definitions and classification. Now, you should remember the real number system. You've got natural numbers, n, 1, 2, 3, 4, 5, 6, 7. Whole numbers, 0, 1, 2, 3, 4, 5, 6, 7, keep on going. Integers, positive and negative numbers. Notice there are no decimals. So minus 6, minus 5, minus 4. Then you have rational. Any number you can write as a fraction, like 7/3, minus 5/9. All those can be written as fractions with decimals. So the decimal that you can turn into a fraction is rational. Now, we do have reals. Irrational, my apologies. So we abbreviate this IRR because we have i's in irrational, i's in integers. With irrational, they're the square roots of some number or pi. And, oh yes, we also have real numbers. Now, we've got 2 R's. Real numbers, we give 2 strokes down like that. There's a fancy name for it, I'll be down if I can remember. Anyway, so I want you to look at this classification system, and note if you're in the classroom, I have this poster up on the wall, giving you definitions. So, what I need you to be able to do is look at these numbers and go, what's the smallest category the following numbers fall under? For example, minus 3. What is that? Is it a natural number? No. Is it a whole number? No. The first place you see it is here, integers. So minus 3 is an integer. I'm going to be lazy and call it I because I'm lazy. Now, I want you guys to pause the recording. I want you to classify these numbers, then I want you to come back and compare answers. Okay? Alright, now 152 is a whole number. Oh, wait, sorry, my apologies. It's a natural number. So I just lazy call it n. 0 is a whole number. So I call this W. 1.345136. Here, that is a rational number. Actually, I'm sorry, it's irrational. You cannot turn that into a decimal. On the other hand, 1.333333, if you grab Mr. Graphing Calculator, if you don't have one, see me. The math button in the very first button says fraction equals this should spit out 4/3, which makes it a fraction. So your graphing calculator will turn a decimal into a fraction if it can. Since it's a fraction, it's rational. If you don't know how to do that, see me in class and I'll show you. And then we look at the last one, minus 4.8, we do the exact same thing, math. Fraction button comes up, you hit equals, and this becomes, now, doing it the long way, that's minus 48 over 10. As your calculator should call it minus 24 over 5. Makes it rational. Do you remember the definitions, and can you use your graphing calculator? I hope so, and I hope so. If not, see me in class, and I'll give you some help with this. All right? Now, if you have any problems with this, go back and review. Otherwise, we're going to keep on going. So here's an example. We have another Venn diagram. As I said, this is what we call a Venn diagram. Tomorrow or next class, we will spend more time on this. But for the moment, notice it's a nice, neat way to organize information. So, first question, what do the letters W, M, B, C, and A likely stand for? I'm confused. You've got M, which is dogs, rabbits, ferrets, and cats. B, which is parrots, lovebirds, macaws. C, which is iguanas and snakes. W, which includes M and B, and then A, which is everything. Well, I think B stands for birds. That makes sense. Parrots, lovebirds, macaws, all birds. So then we look at dogs, rabbits, ferrets, and cats. Besides being furry and tasty, what are they all? Mammals. I think they spell mammals correct. Now, mammals and birds are what? Well, iguanas and snakes are cold-blooded. So, yeah, these are warm-blooded. And A wouldn't be all, it would be animals. Alright? So, a minor part, can you guess what the letters stand for? You'll see in math we use a lot of abbreviations because we're lazy. I mean, economical, learning, and you can't spell. Now, name any disjointed sets. So remember, the disjointed means they do not connect. So, I'm going to redraw that. Let's go back here. Which two groups are not connected or touch? Well, right off the bat, mammals and birds are disjointed. Yeah, I'm not going to write it out because I'm lazy. I mean, economical with my energy. Now, what else? What other sets are disjointed? Well, warm and cold. You can be warm, or you can be warm-blooded, you can be cold-blooded, you can't be both. Now, if you want to get picky, there are other disjointed sets. Mammals and what? Cold-blooded. They're entirely separate. You can be a mammal or you can be cold-blooded. You can't be both. And that leaves what other disjointed set? Birds and cold-blooded. Okay, so I want you to look at that and realize they're not sharing anything. You're a mammal or you're a bird. You're warm-blooded or you're cold-blooded. You're a mammal or you're cold-blooded, you're a bird or you're cold-blooded. And somebody will usually go, Mr. Sutton, can we write bird and mammal? Does it have to be mammal first? No. What you're saying here is these two sets are separate, disjointed, not connected, no overlap, nothing in common. Doesn't really matter which way you write them. Okay? Now, next bit, show which sets are subsets using set notation. So what is a smaller part of something bigger? Well, right off the bat, I see mammals are a subset of warm-blooded. Birds are a subset of warm-blooded. Yes, actually, I'm going to change that just to emphasize something here. This one purple. This one black. Now, the reason I'm changing colors is to emphasize a couple of things. Mammals mammals are a subset of warm-blooded, but warm-blooded is a subset of all animals. So I can define this. Mammals are a subset of warm-blooded, which are a subset of animals. Birds are a subset of warm-blooded, which are also a subset of animals. And we have cold-blooded, a subset of animals. And I suppose I could just say warm-blooded is a subset of animals. Now, note here, try to make your subset sign. It does have its own technical name, and I don't have my brain back to remember what it is. But try to be neat and make certain it doesn't look like your seed. For example, here, cold-blooded are a subset of animals. Maybe make this just a smidge longer so it really doesn't look like a seed. Please be careful about that. Okay? Now, last question. Which subset would be equal to a subset of fur-bearing animals? Okay, what is Mr. Sutton saying? Well, Mr. Sutton's throwing a word question at you. Equal to, same as. Which subset will be equal to or the same as a subset of fur-bearing animals? Well, what are the fur-bearing animals? Those of you in biology go mammals. So I'm going to throw weird questions at you like this. We've got to turn it into English. All right? Now I'm going to stop there because I don't want any video to be that long. If you are taking the diploma, watch the next video. If you're not doing the diploma, skip to the last one. All right?